Section 10.0 Number Lines. Essential question. How do you locate a square root on a number line? So this lesson will be all about placing different types of numbers on number lines. Not all square roots, they'll also be decimals and fractions. So first of all, a square root looks something like this. I'm just going to put X under there for right now until we get into actual numbers. A perfect square root looks something like this, like the square root of 49. And the reason why 49 is a perfect square root, 7, is because 7 times 7 equals 49. So if a number times itself equals that other number, it's a perfect square root. So one other example would be the square root of 25. The square root of 25 is 5 because 5 times 5 equals 25. Integers are just negative numbers and their opposites. So like -3, -2, -1, 0, 1, 2, 3. Generally numbers that you would see on a number line. And it can go in each direction. All right, which numbers are perfect squares? So we have two circles up here. One circle that says perfect square and one circle that says not a perfect square. Remember, a perfect square is where a number times itself equals that number. And we're not going to do all of these numbers, we're just going to do some of them. Feel free to write them into the circle. You don't have to write them on the left-hand side if you don't want to in your notes. Just drag them over to the correct circle. So I'm going to start with some perfect squares. So 100 is a perfect square because 10 times 10 is 100. 36 is a perfect square. 6 times 6 is 36. 81 is a perfect square. 9 times 9 is 81. 16 is a perfect square. 4 times 4 is 16. 49 is a perfect square. 7 times 7 is 49. See if you can bring a couple of the other ones over as well if you want to. Now, not a perfect square, 18. There's no number times itself that would make 18. 15, 24, 40, 55. One good one to bring over to perfect squares is actually 1, because sometimes people get that one mixed up, but the square root of 1 is just 1. And if you want to write a couple reasons why in your notes here, square root of 10, 100 is 10, 36 is 6, 16 is 4. So those are why those are perfect squares. If you took the square root of 40, 18, 24, 15, 55 in your calculator, you would get a big long decimal that continues forever and doesn't repeat. All right, name the first 10 perfect squares. So this list we're going to get a lot of use out of in the first few slides in this lesson. So make sure you make this list in your notes. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. So while you're writing those, I'm going to take a second and group these together and copy and paste them because we will want them for our next page. All right, so on this page, we are going to look at a bunch of different square roots and place them onto a number line. So write down the directions, find the integers these square roots fall between, and graph. So what you'll notice about all of these square roots is they are all non-perfect squares. So this whole list are So none of them are going to go directly onto a number on the number line. They're all going to fall in between two numbers on our number line, two integers on our number line. Okay, so the square root of 17. If I drag that over to where it falls in my chart, 17 is in between 16 and 25, which means it falls between the integers 4 and 5. So I'm going to bring it down in between the 4 and 5. The negative square root of 24. 24 also falls between 16 and 25, except it's negative. So the integers it's going to land between are negative 4 and negative 5. So for example, for the square root of 17, if I took my calculator and figured out the square root of 17, it would give me a big long decimal that started with 4 point something, because it's between 4 and 5. If I took the negative square root of 24 in my calculator, I get a decimal that's negative 4 point something. Keep in mind though, for this lesson, you should not be using a calculator. You would not be able to use a calculator on these questions on your MCAs, and you will not be able to on your test either. So do not use a calculator. All right, the square root of 5 falls between 4 and 9, which is the integers 2 and 3. The negative square root of 2 falls between 1 and 4, which is the integers negative 1 and negative 2. Square root of 22 falls between 4 and 5. So again, the integers 4 and 5. And the negative square root of 11 falls between negative 3 and negative 4, because it's between 9 and 16. Put that one up above there so that it's not covering up the negative square root of 24. All right, so that is how you place non-perfect square roots onto a number line. All right, graph each of these decimals on a number line. So make a number line from negative 5 to 5. Let's start by doing the positives first. They're the easiest. So 1.75. That's going to go in between 1 and 2 and a little closer to 2. 4.5 is in between 4 and 5, directly in the middle because it's 0.5. And 3.2 is between 3 and 4, a little bit after the 3 because it's 0.2. All right, our three negatives. Negative 2.5 is in between negative 2 and negative 3. Negative 4.1 is just a little bit beyond the negative 4. And negative 1.25 is to the left of negative 1. So those are where the negatives would go. So if it's a negative number and a little bit more, it goes between the negative of that number and one number smaller. All right, I'm going to add a screen to this one before we do this. Okay. So you are going to need to write down the directions, which fractions and decimals are graphed below. Then you are going to make yourselves a number line. Your number line is going to have the numbers 1, 2, and 3 on it. Then the important part is how many lines go in between each number. So in between 1 and 2, there are 4 lines, and in between 2 and 3, there are 4 lines. There's always going to be the same number of lines in between each integer. So make sure you put 4 lines in between each integer, and then put the red dot where my red dot is located. Okay, I think it's easiest to write this as a fraction first before I turn it into a decimal. So since my red dot falls between 2 and 3, it's going to be 2 and a little bit more. So here is how you count the lines. We start at the 2, but don't count the line at the 2. We start with 1, then 2, 3, 4, 5. So 2 and 4 fifths. I'll show you how I did that again with my red marker. So don't count the line for the 2. 1, 2, 3, 4, 5. All right. Now we need to turn that into a decimal. So it's going to be 2 point something. Now I don't know what 4 fifths is as a decimal. And I can't use my calculator because we can't use calculators in this lesson. So we're going to need to do long division. So take the top number and put it inside, and the bottom number and put that outside. 5 can't go into 4, so I'm going to have to add a 0. 5 can go into 40 8 times. So 0.8 is my decimal. So 2.8. All right, second one. This number line is going to be different than the last one, so don't try and use the top one again and just put a new red dot on it. It is different. So write down the integers 1, 2, and 3. And then you're going to count the lines in between them. So we have 1, 2, 3 lines in between 1 and 2. 1, 2, 3 lines in between 2 and 3. So put 3 lines in between each integer. All right, now we're going to look at where the red dot is. It's between 1 and 2, so it's going to be 1 and some amount. When I start counting, I don't count the line at the 1, but I'll start here. 1, 2, 3, 4. So 1 and 3/4. Now some of you may know what 3/4 is as a decimal, but if you don't, we'll still do the long division. So the 3 goes underneath the division bar. 4 is on the outside. 4 cannot go into 3, so I'll add a 0. 4 can go into 30 7 times. 4 times 7 is 28. So then that's 2. Bring down a 0. 4 can go into 20 5 times, and then bring my decimal up. So 1.75 is my decimal for that one. All right, one more like that. So now I have one big long number line with just 2 integers on it, 1 and 2. And then the number of lines you should make in between are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 lines in between your 1 and 2. Since our dot is in between 1 and 2, it's going to be 1 and some amount. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 and 7 tenths. And then if I do the long division for that, 7 divided by 10, 7 goes on the inside, 10 goes on the outside. 10 can't go into 7, but it can go into 70. So 10 goes into 7 times. So 1.7 is my answer. All right, last slide. Graph each of these fractions on a number line. So make a number line, and then we're just going to drag the fractions over to where they belong. I'm going to do all the positives first. So 3 2/3 falls between 3 and 4. 1 1/2 falls between 1 and 2. 2 3/4 falls between 2 and 3. 4 7/10 falls between 4 and 5. -4 1/6 is in between -4 and -5. -2 3/5. -3 1/4. And -1 1/5. Summary.